All right, here's a problem that we actually can't do without change of variables. The previous ones where change of variables made it easier, but this one we can't do. Why can't we do it? If we just try to integrate this function e to the x plus y over x minus y with respect to x and y, I don't really know how to integrate that. I've got e to an exponent that's a fraction, and I have the variable in the numerator and the denominator. I could sit and try to make it a proper fraction. Like I have some tricks for this. One thing I might try is I write x minus y plus 2y. Then I haven't changed the numerator, and then this is 1 plus 2y over x minus y. That's better. Now I'm trying to integrate e to this exponent. It's a little bit better. X is only in the denominator. And if I don't like that 1, that's really e times, like it's e to the 1 times e to the other fraction. Okay, that looks even better. It's still not great. I don't know how to integrate that. What's the integral of e to the 1 over x anyways? So, I don't know. This might be difficult. If we do a change of variables, we can make it a lot easier. So, let's do this. And some of the WebAssign problems might tell you what the change of variables is. Sometimes you might have to, maybe not on WebAssign, so maybe on quiz 2, you might have to figure this out yourself. But if I put u equal x plus y and b equal x minus y, that'll at least make the power in the fraction a lot easier. So that might work. Now I need functions of x and y in terms of u, right? So I actually need to, if I add the two equations, I get 2x equals u plus b. So that means x equals 1/2 times u plus b. And then if I subtract the two equations, I get 2y equals u minus b. So y is 1/2 times u minus b. Okay, that's my change of variables. I can calculate the determinant of the Jacobian. The Jacobian is going to be nice. I'm going to take partial derivative with respect to u for x and get 1/2. With respect to v gets 1/2. Y is 1/2, negative 1/2. That's great. So that's negative 1/4 minus 1/4 is negative 1/2. Absolute value of that is 1/2. Okay, so that's good. And then I need to integrate. So I'll integrate this function, substitute the variables in. So this is e to the u over v. I have my determinant, my absolute value of determinant of Jacobian is 1/2. And then I have my du dv, and I just need to figure out now actually the region. So I might need to draw a picture. So let's figure out what the original region was. X and y. Let's see. I have 1, 0, 2, 0, 0, -2, maybe make this a little bit longer, 0, -2, and 0, -1. Okay, so is this slanted little trapezoid? And then what happens to these? So I'm going to translate to u, v. So I have x plus y, x minus y. So this turns into 1, 1, doing x plus y, x minus y, 2, 2. This is -2, positive 2. And this one is -1, positive 1. Okay, so now in my UV plane, I can plot those points. 1, 1, 2, 2, -2, 2, -2, or -1, 1. I get now this trapezoid. Okay, that's actually better to integrate, because over here, if I drew horizontal or vertical lines, I would end up having to divide the region into two pieces. So I like this a lot better. I can just draw horizontal lines. So that's great. That is the way I have it set up. V is on the outside. So V goes from 1 to 2. And then this is the line u equals v, because it came from the points 1, 1, and 2, 2. This is the line u equals -v. So for every value of v, yeah, u goes from negative v to positive v. And now I can integrate that. And hopefully this works out. There's no guarantees at this point that this will work out. It looks like it might be nice. Let me put my 1/2 out in front so I make it a little easier. Integral from 1 to 2. Integrating with respect to u. So e to any power is itself, and I need to do the chain rule in reverse, or a u substitution. It would be a w substitution maybe. I've already have letters u and v, but I get a v out there. Let's just make sure. If I take the derivative of this, I get back to e to the u over v. That seems to work out because I end up with a 1 over v, which will cancel out with this v. Okay, so that's the integral. I need to go from u equals negative v to u equals positive v, and then later I'll still need to integrate with respect to v. So I get 1/2 integral from 1 to 2, and then I'm plugging in bounds. So this is v times e to the 1, right? V over v is 1, minus v times e to the negative 1, so v over e, actually, dv. Okay, so then really I can take a 1/2 e minus 1 over e out as a constant, and then I'm just integrating 1 to 2 of v dv. That's good, that's easy. 1/2 e minus 1 over e, and then this is v squared over 2. Plugging in v goes from 1 to 2. I get 1/2 e minus 1 over e. This will be 2 minus 1/2 for a total of 3/2 times the 1/2 out there. So 3/4 times e minus 1 over e. And this is a lot better than what I was doing before. I was trying to simplify x plus y over x minus y, and it still looked like the integral was going to be hard.